if you think about what life is, first of all, think for a second, where is life in the universe? Well, right now, we only know that there is life on planet Earth. Now, what is life? Is a virus alive? Is a donkey alive? Is a human being alive? Is my mobile phone alive? I want you to take a moment to think about those. Is a donkey alive? Is my mobile phone alive? Is a virus alive? Is a human being alive? Is my sandcastle alive? Okay, let's take them in reverse order. Is a sandcastle alive? Yes. Is a virus alive? Yes. Is my mobile phone alive? Yes. Is a donkey alive? Yes. Is a human being alive? Yes. You're like thinking, well, if they're all alive, what's dead? Well, maybe if I took some sand that wasn't in the sandcastle, that would be dead. If I took some rocks, maybe that's dead. Now, this seems kind of really counterintuitive. A virus, surely a virus isn't alive. Well, no, actually, you're right. A virus itself isn't functionally alive, but as soon as you put a virus into a cell, it replicates. Let's take a sandcastle. Is a sandcastle alive? No, actually, that's ludicrous. But the sandcastle was made by a human being. They put the sandcastle there. So now maybe you then might go, oh, actually, no, Lee, what you said before was wrong. What you mean is the sandcastle evidence of life? Yes. Is the virus evidence of life? Yes. Is the human being evidence of life? Yes. Because all these objects, apart from the sand and the rocks, were produced by a thing called evolution. So evolution in biology is this process of you have genes that get propagated in cells, and as the cells grow and replicate, some live and some die, because some have good fit genes and they are able to live in the environment extremely well, and others have an error and they may not live for very long enough to propagate. So this is the essence of what life is. Life is this kind of continuum between birth, living the environment, and hopefully replicating yourself before you die. Now, how did COVID do it? Well, COVID was a bit cheeky because COVID basically got replicated in a cell in someone's lungs or in their nasal cavity, expelled out, and the COVID, while it's out in the atmosphere, is functionally dead or not alive, but as soon as you breathe it in and it goes into your cell, it's alive again. It's able to replicate itself. And so this expands the concept of life to being slightly bigger. It's not just about a single cell, a bacterial cell that you might find in the environment, or one of your skin cells that's continually growing, or your hair or whatever, or your nails, right? You can see the product of life. So life and being alive are actually very subtly connected, and it's probably going to blow your minds. So I would basically say, what is life? Well, life is a thing that can build objects that are complicated. So think about that for a second. Life is a thing that can build objects that are complicated, but now we need to add on something else in abundance, a large number. So if I painted a picture, or I made a picture in the sand, and you saw it on a beach, you might say, oh, there's a chance that picture could have emerged. It could have just happened by accident. But let's say the picture was like a house, and I put my windows in, I had a chimney pot, and it was quite clear. And I did 10 identical copies of that house on the beach. You'd be like, wow, the chance of some freak wave or wind riding 10 identical houses in the sand would be very low. And the larger the number of houses drawn in the sand, the lower the chance. It's a bit like flicking a coin. Do I get heads or tails? 50% chance. Flicking it again, 50, and then it goes down, goes down. If you flick your coin, how many times do you have to flick a heads in a row before you think, oh, this is cheating, someone has weighted my coin? It's probably not very many. It's probably about 10 or 20 times. You might just think you're a super lucky person. So life is best described by processes that can make complex objects in large numbers. So if you went to the Apple store and you saw 1,000 iPhones, you could conclude, even if there was no one in the iPhone, you were on Mars, and you just found an Apple store on Mars with 1,000 iPhones, you'd be saying, okay, there's life on Mars somewhere, or Apple has set up a store on Mars. This may seem a bit weird, but bear with me. I'm kind of trying to build this up because we need to work out how to find aliens without any knowledge of what life is in anywhere else in the universe. We have to come up with the most abstract definition of life. And what you might want to do is imagine for yourself the consequences of that. So go into the environment. Can I imagine an object in the environment that is complex and got large numbers of things? Is it related to life in some way? So if you see a motor car, related to life. Humans had to build it. Find some drugs. Some drugs, they had to be built by human beings. And so you could really see all these examples. In fact, I challenge you to think of an object that can appear in large numbers that are identical, that would be alive. Now, let me give you a couple that you might think would work, and they don't. Snowflakes. Snowflakes are never identical when they get out to large enough, kind of when they're complex enough. Simple snowflakes, you can have a large number of copies. Large snowflakes, impossible. Maybe you could say fire. Is fire alive? Well, no, fire's not alive because you don't have identical motifs. So this idea of life being this process that makes complexity in high numbers sets the scene. So where are the aliens? Well, this is what I'm going to spend the rest of the time going through this mini-series and explain to you how we're going to use this notion of complexity and the fact that life is able to build things that are complex in large numbers and try and look for those aliens. Before we do that, let's just think about what we're looking for right now. So classically, our civilization has been looking for aliens for about, I don't know, using technology for about 100 years, let's say, right? Since we started to broadcast radio signals. So initially we'd say, okay, we'll listen with a big earphone, do radio astronomy and listen to sound coming from space. And maybe someone's broadcasting as a message. That's a legitimately good idea. Maybe we'll look up and look for laser pulses to see if someone encoded something. Maybe we might try and find evidence of weird things around other stars. There's a thing called a Dyson sphere, where Freeman Dyson imagined that aliens, sophisticated enough, could take a star and wrap a solar panel all the way around the star to capture all the energy because it was super greedy. And that star would basically look like a black hole, but wouldn't quite be a black hole. It would have a different signature, or there'd be, a characteristic signature associated with that Dyson sphere. So you'd kind of look for technology using our telescopes like the Hubble and the James Webb. The other problem about looking for aliens is the universe is expanding and we're traveling far away from one another, so the only way we can really look in the distance is looking at signals. The radio, looking at signals traveling at the speed of light, so radiation. So how can we look for evidence of life from radiation when I've just told you that life, biochemical life anyway, has these intrinsic local properties? And this is something that's really important for us if we're, as a species, we're going to find out, what life is on Earth. Is there life elsewhere in the universe? How rare is life? And what is the future of life on Earth, right? These are all, big questions. And some people may say that, what we call large language models, these pieces of software that run ChatGPT are alive. Well, they are alive insofar as a sandcastle is evidence of life, but they're not alive themselves. And understanding this mini-series about complexity and aliens will help us put that into context.